Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hello and welcome to Hardware to Save a Planet. I'm here with Andrew Gillies, the CTO and co-founder of Urban Machine. Andrew and his team are on a mission to reclaim the millions of tons of wood waste from construction and demolition into high-volume, locally sourced lumber. I personally love this because it combines two of my favorite things, turning wood waste into a valuable resource and construction. It's also addressing a big problem. Wood accounts for 10% of all materials in landfills, and building with reclaimed lumber has a carbon impact 13 times lower than using new material. To introduce Andrew quickly, he's an engineer, entrepreneur, and team builder with a Ph.D. in biomechanical engineering from UC Berkeley. Prior to Urban Machine, he was the co-founder of Dash Robotics, where he developed and shipped hundreds of thousands of consumer robots with over 5.5-star ratings on Amazon, which is super impressive. He's also worked on robotics for agriculture and solar panel cleaning, and his research at Berkeley included going deep on mimicking gecko foot adhesion. He strikes me as someone who's as passionate about making an impact on the world as he is about the innovation process to get there. Andrew, it's really an honor to have you on the show. Thanks so much for joining.
Thanks for having me, Dylan. Excited to chat.
I just have to start with your work in mimicking gecko foot adhesion because it's something I've heard about my whole life as an engineer, but I've never actually met someone who's actually worked on it personally. I'd love to hear what your approach to it was and what you learned.
Yeah, absolutely. It's such a wild little problem to work on. And my PhD was incredibly exciting. It really mixed a lot of my passions. I've always been really attracted to the sort of intersection of biology and engineering. And this was just right in the bullseye for me. It was a really challenging problem. Chasing down this extremely fine structure that biology's come up with, very challenging from a fabrication perspective. I came into the project. The project already had a few years under its belt at Berkeley when I started on it. So there's some history I was stepping into there. And we were frankly hitting a little bit of a ceiling with the techniques we were applying. And I came in trying to sort of expand the scope of that. So the thing that's really magical about the gecko foot pads is this extremely hierarchical structure. It sort of starts at this macro scale. So think sort of millimeter scale structures. And then you have this continuous branching and narrowing of these features until you're literally at the nanometer scale. Their foot pads are almost like these forests, right? Like imagine this like huge bunch of trees, you have the big stalk, and then at the end you have these little leaves. They call them spatulae. And then it's literally because they look like a little spatula. And those features are about 10 nanometers across. And it's beautiful to look at these things. It's incredibly inspiring. We don't really have fabrication techniques that can chase that many orders of magnitude in structure, right? Like you have these different camps. You have obviously larger scale fabrication techniques where you can do some amount of like molding at the sort of millimeter micron scale, like hundreds of micron scale. And then you have like lithography techniques like they use in semiconductors that can get into the nanometers. There's no crossover between those worlds. There's this huge chasm, this sort of like middle scale, sort of tens of nanometers to tens of microns. It's a blind spot. And that's where I spent a lot of my time during my PhD trying to figure out how do we narrow in on that. So we came up with all sorts of ways of like sort of blending these things together, looking at things like laser micro machining and micro molding. It was probably a longer process than I had for my 5 years at Berkeley to take. So we had some wins, we had some applications, but there's much more work to do there to span that chasm.
Do you think we'll get there eventually?
I think we will. I think that we'll probably need to come up with more radical approaches, more bottom-up approaches, things that I find really inspiring in that space. Follow the sort of train of thought. I'm not sure if you've heard of Eric Drexler. He has this whole atomic precise manufacturing paradigm. It's more like doubling down on the biomimicry and looking at things like protein synthesis, where you program some like nanoscale devices, or you literally use like machines from cells, like you use like DNA synthesis techniques, and you build up structures that way from the ground up, literally hijacking biology. So I think that could be a way forward. But I think there's a lot more academic research that needs to be done in that space before we see commercial applications.
Cool. Okay, so from kind of nanoscale to Urban Machine is a much bigger scale. I'd love to hear what's been your path to get from there to where you are today.
Yeah, it's kind of funny. I feel like everything I've worked on since grad school has just been bigger and bigger. Like right after grad school, some folks from the lab and I founded a company called Dash Robotics. We were working on, it was a consumer product, educational robot toy for kids. And it was sort of this fold up origami type structure that we could manufacture in sort of a 2D roll to roll process that was technology that came out of the Ron Fearing's lab at UC Berkeley. Sort of ran its course through the whole, there's this wave of IoT, sort of an explosion of IoT Bluetooth connected toys that happened there from like 2013 to 2018. That sort of fizzled out. And after that, I knew I really enjoyed the entrepreneurial journey. I really enjoyed the sort of just the early dirty phases of being in a startup and the excitement and the creativity and all that. So I knew I wanted to do that again. And also, obviously, climate, sustainability were big topics, like getting more just airtime and like the problems are all in our faces so much more. So at that point, it's like I really wanted to start directing my effort towards that. So I started to look for projects that were in that space. And I frankly struggled with the specific problem that I wanted to work on. So I sort of fell into this contracting mode. I was like, I'll just help other teams develop their early phase technology and see if anything sort of catches my attention, it sort of fits my skill set, and I think has some sort of positive impact. Worked on a lot, you mentioned some of them, worked on some really cool projects, worked closely with a startup called Root Applied Sciences, and they're creating a sensor to allow for precision pest control in agriculture. So we built this little solar powered IoT device that would collect information about fungus on like lettuce fields or in grapes and allow for precision application of pesticides. That was a super fun project, really opened my eyes to like, wow, you can get in there, you can do some quick and dirty prototyping and sort of go on that sort of journey and have a positive impact and have a great business opportunity at the same time. That was the thing that was really, I mean, it's like, wow, we're saving the farmers tons of money and we're saving a ton of pesticide application. That was the first big project into this sustainability, climate impact space. So through some of the contracting work, I met my current co-founder, Eric Waugh. We had collaborated on some automation projects in the construction space. So he was leading the innovation team at Swinnerton Builders, which is large GC firms, like multi-billion-dollar GC firms on the West Coast here. And he was scoping out how automation could have an impact on their business. He was also really passionate about sustainability. We had worked on some early projects together at Swinnerton. And then at one point, I reached out to him just to check back in on stuff. And he said, I have this problem that I see within Swinnerton. It's this wood waste problem, just the construction and demolition waste. And it seems really unnecessary that we're throwing out all this lumber. It seems like we can do a better way. And potentially we could do this. Automation could play a role in solving this problem. So we started to chat about that. That was summer 21. So really not that long ago, a little under 2 years ago. It's been a roller coaster. And as soon as he started describing the problem, it immediately checked all my boxes, right? Like need for sustainability, impact on sustainability, huge business opportunity, and fit my skill set really well, which is like bringing hardware, robotics, and automation in order to solve this. So really quickly, I was super excited about it. We started doing some early brainstorming, and then we were off to the races.
And why not do it inside Swinnerton? How did it become a separate company?
Yeah, that's a good question. I think that it's probably a little too weird for something. I can't speak directly for Swinnerton. I wasn't there, but my assumption is it's like a lot of these situations are you just need something, a totally separate entity in order to have the elbow room to go do something totally crazy. I don't think the construction industry has a track record of plowing a lot of money into R&D. This is one of the big trends. McKinsey wrote this a few years ago on sort of productivity gains across different industries. And construction was like way down at the bottom of the list. They've really struggled with plowing more money into productivity gains and investing in R&D. So I just don't think that industry is set up well to incubate innovation internally. That's my impression of it. Yeah. And Eric had been a startup founder previously. He had done a couple startups before he was at Swinnerton. So he knew the mechanics on both sides. So I think he probably saw that, yeah, this is going to be better outside.
Yeah, I think I've seen that report or something similar, and maybe it was the same thing, but also just talking about how it's kind of the most untapped area for potential automation applications, construction generally.
This is the market size part of it. Construction, like the built environment is the biggest market, is the biggest industry. It's just everywhere. It's everything we touch. It's a huge part of the emissions picture as well, both from the production of materials and from the operating of these buildings. It's just this mega industry. So any small problem that you find in construction is almost de facto a huge market. That's like the thing I keep coming back to. It's like, oh, this seems like some weird, obscure thing, but it's happening everywhere all the time, every year. So it adds up to some huge problem. So yeah, I think, massive opportunity for automation and robotics in construction, massive opportunity to, bring costs down, make more sustainable, more affordable housing. There's lots there to work on.
And then let's talk about this, what you're doing from a sustainability standpoint. What is it that made this such a clear win for the planet?
EPA studies show us 37 million tons of waste lumber that we send to landfills every year. And it's not a very pretty picture what the current state of play is. There are dedicated construction and demolition recycling facilities that will take in and process this material. But the unfortunate reality is for lumber right now, there's just not really good recycling. There's not good uses for that material once it arrives on that recycling site. So steel and concrete are interesting. There's very established recycled waste for those. So there's a tremendous amount of reuse for steel, and even concrete gets crushed down and used for aggregate. So they're not really a problem. No one's figured out what to do with the lumber yet. So right now what they do is they shred it. So they completely think mulch. Then they separate out any of the contaminants on the fasteners, nails, screw staples, that sort of thing. They separate it all out of the mulch with magnets. And then 70% of that mulch gets burnt in incinerators. They just burn it and shoot up into the atmosphere. They do this at cogen plants, so they're capturing some amount of electricity off of it. That process is fairly problematic, though. The first big problem is that it's a pretty dirty fuel. It's not clean burning. It's not natural gas is fairly clean burning in terms of if you're going to burn a carbon-based substance, natural gas is fairly clean. Wood is not to burn. So the EPA is not super happy with that, and they're looking for ways to effectively stamp that process out. The second big problem with burning the mulch is that it's no longer economical, especially in places like California. It's no longer economical competing against things like solar and wind. It's just an expensive process to run. This blew me away when I found this out, but the recycling centers actually have to pay the cogen plants to take the fuel away.
Oh, wow.
So they're getting paid to burn stuff. That's how the economics are in that direction. So they're, even without the EPA trying to force the issue, they're shutting down just based on not being profitable enough to operate. So all that adds up to, we don't have a place to put all this material. We're running out of places to put this stuff. When you couple that with the amount of urbanization that's happening, where you have just urban turnover, there's just this massive amount of material piling up at these centers, and they're starting to look at these literal mountains of lumber and saying, what are we going to do with all this stuff? We can't burn it. There's no real use for it right now. We don't have land to stick this stuff. Like we're out of options. Some of those folks at the waste facilities call it Woodageddon because they're just overwhelmed with this. Yeah, so that's kind of the setup for the problem. So you have the carbon impact from burning it, and it's just like nowhere to stick this stuff. And then you have this urbanization force. We're just generating more and more of this material. There's the other side of the problem, which is an acceleration in the use of virgin lumber that we're taking out of forests, right? So you have all the challenges around deforestation, climate pressure on forests, right? Like forest fires and drought and all these things that are putting pressure on our normal sources of lumber. And then you also have, we saw this through COVID famously, the price of lumber just skyrocketing and shooting up and just being incredibly unstable. So there's this pricing challenge as well with lumber. The price is just extremely volatile, which impacts housing affordability. So there's a direct connection there. So all that amounts is just like a lot of challenges with how we're moving lumber through the built environment.
So when we think about it from like purely a greenhouse gas emission standpoint, it's mostly about preventing the burning of the wood and less of it. I was thinking like, is it about the actual like emissions from deforestation and transportation and processing of the lumber and that kind of stuff? Or is it primarily about that burning at the end of life?
Yeah, I think it's a combination of both of those things. So there's the burning and the releasing of that into the atmosphere if it's just going to go to landfill. But if you can recover it and you can use reclaimed lumber in your building versus virgin lumber, it actually has 1/13 the carbon impact. There's a huge benefit of using reclaimed lumber in your structure. One of the dirtiest steps for virgin lumber that was also not on my radar, which is stunning, is drying the lumber after it's been harvested. You have to get the water content of that lumber down to 4% or so after it comes to forest. The way they do that is they have these giant kilns. Like think these like huge warehouse-sized kilns. They literally drive train cars into these things full of lumber, and they have to heat them up. It's like a wood sauna, and it takes a tremendous amount of energy to heat these things up and to dry out that lumber. It's one of the most polluting steps in the entire chain. Like compared to transportation is a fairly small sliver of it compared to the kiln drying of the wood. And with reclaimed lumber, you just don't have to do that. It's already dried, or it just came out. It's ready to go. Yeah, so 1/3. So it's significantly better to use reclaimed lumber in your structure. We've just started to get into looking at a full life cycle analysis of our material versus virgin to understand. There's obviously more market dynamics at play, right? Like if we're putting our market, and if the wood market is growing, how much virgin lumber are we actually able to displace through our process? So there's like more complicated market dynamics questions there that I don't think we fully understand yet. But if you just look at a single structure as a 1-to-1 replacement, it's 1/13 the impact.
And what is it about wood that makes it so much harder to reuse than steel or concrete and these other materials at these recycling centers?
Yeah, it really comes down to the metal fasteners, the nails and the screws and staples. Steel and concrete are easy because you can pretty much just melt them down or crush them down into aggregate, right? There's not a lot of, it's easy to like climb back up at the entropy well because you just throw it on a big vat and you just cook it. It's just a singular process that you can do in massive scale. You can't do that with wood because the thing that makes these timber products valuable is the length of the fiber, like how intact the fiber is across a beam, right? Once you turn it to mulch, you've destroyed the value because you've shredded the fiber up into all these tiny little sections. Sure, you can do things like plywood or MDF or these other products, but even those are significantly less valuable than having intact lumber. So that's really, if you want to maintain the value there, which you need to capture some value out of it to drive this process at all, right? And so maintaining or capturing the most value means maintaining as much fiber length as you can. And when you have these long beams that are full of metal fasteners, that gets really challenging because now you have to have some sort of surgical process to go in there and identify and separate anything about. People do this for really valuable lumber, right? These little boutique mom and pop type family businesses they'll run around Pennsylvania tearing down barns and pulling out all the nails by hand. And they sell, that's extremely valuable lumber. They sell that for a huge premium. And they have to because you're doing it with human labor. And it's a dirty, dangerous process. And it's slow and you're using human labor, so it's expensive. So you can kind of hit that really sort of tip of the iceberg, the most valuable stuff, but that's really just the tip of the iceberg. There's so much more to do. Yeah, that's where the problem has been, that like you can't apply humans to it, but you need to do this sort of surgical removal process.
Yeah.
That's kind of the crux of the problem.
I guess this is probably obvious, but putting wood with fasteners back into the construction process is going to be bad from all kinds of standpoints. You'll ruin saw blades and I don't know. I'm sure there's all kinds of reasons why you don't want to do that.
Yeah, that's the biggest thing, that absolutely no one will buy this if there's a chance of hitting a nail with their saw blade. There's some really gnarly videos on YouTube of people hitting nails with their bandsaw. It's pretty bad. We play those for the team to remind them, like, the worst thing we could do is send beam with a nail in it to a customer. That's the worst thing. That's really people want to feel really cozy that we've got all the nails out of there. Yeah, it's unsellable if there's any chance of there being nails in there.
And then maybe this is a stupid question too, but should we be trying to move away from wood generally? Like, is it not the right material to be using so much of?
I think it's a phenomenal material. I think we should be doubling down on it. And that's what you're seeing. You're seeing that trend. started in Europe. Now you're seeing it in the US where you have it's called this movement's called mass timber, where you have literal skyscrapers with timber as the structural members coming together. There's a few techniques for doing this. The most popular one is called cross-laminated timber, where they'll take smaller dimensional lumber like 2x4s and they'll stack it up like Jenga blocks, and they'll create sort of 3 or 5 layer panels that can be huge. They can be like 60 feet wide, 10 feet high, a foot thick of just solid lumber. And they make these things in sort of this prefab method. They do a glue layup and they press them all together, and you have these huge slabs that become the structural members for the building. And there's been a lot of work on that showing that it's much more sustainable than steel and concrete. It's great from a carbon capture perspective. People love them from an architectural perspective. They're just really beautiful structures. They're beautiful to occupy. And yeah, I'm excited that trend is taking off in the US. So it's super cool to see that. Actually, in Oakland here, there's a project that just kicked off. I think it's going to be one of the highest mass timber structures in the whole country, right in downtown Oakland here. A couple of folks from our team were able to see that a few weeks ago.
Cool.
So yeah, it's a really cool movement. I think has a lot of promise.
And so what's your business model then? What are you selling and who are your customers?
Yeah, so the business model is pretty straightforward. We have inputs, which is the waste lumber. We get those from free from our partners. We do some processing on it with our proprietary technology. And then out the other end, we get clean lumber that's ready to sell back into the timber products industry. Our customers right now span a few domains, everything from sort of furniture, architectural installation, like facades, roofing, stuff like that. And we're starting to tip into structural applications for our lumber as well. And then in the future, we'll be looking at effectively anywhere that you can use, since you can reform this lumber into so many different uses, anywhere that you get to drop this lumber in. So we're also looking at applying it to mass timber structures as well, seeing if we can be a feedstock into some of these CLT panels. So a variety of uses there. Our early customers are more in the architectural and furniture space, because as we're getting going here, our volumes are just not high enough yet to support the big sort of material hoovers. Like we don't have enough to fully feed a CLT plant right now. We'll get to that in the future. So right now, sort of the smaller boutique use cases as we get going.
Okay. But the longer term vision would be material that's coming out of buildings can go back into buildings.
Yeah, absolutely. In fact, two of the projects that we're working on right now, we're literally showing up on site, processing the lumber, getting it fully clean, and then just leaving the lumber on site. The customer is just going to use that lumber directly in the next project. So it literally never leaves the site. Those are the coolest ones.
That's beautiful. Yeah, very circular. Okay. So you're actually getting the waste, or what was previously waste wood, for free from contractors, because otherwise they would have to bring it to these recycling facilities.
Yep, absolutely. Yeah. So they get dinged twice. They have to pay the hauling, the trucking fees to get it to the recycling center. And then they have to pay tipping fees to the recycling center to leave the material there. So that could be a couple $1,000s a truckload for one of these large haulers. And a commercial or industrial teardown might have 20, 30, could be up to 40 of these hauls coming off of a single site. So they could be out tens to hundreds of thousands of dollars for moving and tipping this material. And so our value shop, and we can make it disappear for free. You just don't have to think about it. Just put it in a corner over here and we'll show up and we'll make it disappear for you.
Mm-hmm. And that means you're literally bringing your robot to that site and processing it there, or you're taking it to kind of a urban machine facility to do that?
Yeah, we're exploring the operating model right now. So we're going down both of those pathways to figure out what's going to be sort of the most operationally efficient method. So we're set up to do both of those. The analogy I like to use for our system is it's like a wood chipper. We have something that mounts on the back of a truck. So it's like a trailer that mounts on the back of a truck. We can drive it to a job site, or we can leave it at sort of a hub and spoke model, like leave it at a certain facility. Our crew shows up with the system. They throw the material into the wood chipper. Instead of chipping it, we have full boards coming, and then we bundle that up and we can ship it to the customer. So our whole system is designed to be mobile.
And I'm just thinking about other stakeholders. What about like cities where you're operating? Do you have any kind of tailwinds where this is supported by planning departments and that kind of thing?
Absolutely. We have huge tailwinds. So that's one of the other things that excited me about this opportunity is we have so many tailwinds, and cities are very engaged with us. They see this problem. They're dealing with the overflow in the recycling center. So they're really motivated to figure this out. You're seeing more and more cities put deconstruction ordinances in place. So Portland has already done this. Palo Alto has already done this. You're seeing more and more cities put this in place where they're mandating that buildings have to be taken down in a certain way. They can't just be like smashed up and taken to a landfill. So they're behind this. They're also behind setting up dedicated more or towards reuse recycling centers instead of sort of smashing it up how the current ones do it. So we're actually working with a handful of cities to look at creating dedicated lumber processing facilities in their area to help process material for them. And there's several government grants or funding opportunities from sort of the state and federal level that the city, like we're co-applying alongside the cities to get some funding to help them set up these centers.
I want to hear about the hardware.
Yeah.
Could you start by just kind of describing what your robot does and what it looks like, that kind of thing?
Yeah, I think at the highest level is so we're focused on dimensional lumber at first. So you have a large timber beam that's full of nails. You stick it in our machine one side full of nails and it comes out the other side with no nails in it. That's sort of the highest level. And the way we do that is sort of like an Amazon pick and place robot, like one of these robots you see bin picking. So it's a pretty classic robotics problem, which is perceive some objects, and then go and do some sort of grasping or manipulation on it. So our system, you can kind of think about it as this long tunnel. And on each sides of the tunnel, we have these gantry robot arms with these pretty vicious little grippers in them. We also have cameras inside this tunnel. So we drive the wood through this tunnel and we built a perception stack to look at the lumber from all four sides and detect all the fasteners as it's passing through the tunnel. We get a lot of information on each of the fasteners as it's coming through there, alongside its 3D pose, like where is in 3D space. We also look at the geometry of the nails. As you can imagine, we see a lot of crazy stuff. We see like all sorts of different configurations. We call them fastener stories internally. Each of those stories, so you can imagine there's like bent over nails, flush nails, nails protruding from the surface, nails tangled together, nails bent over the other side, broken off nails. We have a whole list of these things, and we can classify all of those and get a bunch of data on those from our perception stack. And then from there, we have on a removal technique based on that fastener story. And that removal technique, we do some trajectory planning with our robot gantries. We decide when and where is the best place to pick that. And then we fire that trajectory off to our robot arms. They go in there and start removing the fasteners. Yeah. And then as we're rolling out the far side of this, we have a giant metal detector that's extremely sensitive. So every piece has gone through the metal detector. It can pick up a single leg of a staple. That's how sensitive our metal detector is.
Wow.
Yeah, so we brought it through as a final QC step to make sure that it's fully metal free.
Okay, because sometimes maybe there's something embedded in it or hidden in a way that the robot can't visually see it.
Yeah, absolutely. And there's, as you can imagine, there's also a pretty long tail of fasteners that are just weird things that we're seeing for the first time. We do have a pre-processing step that we do with the crew to make sure there's nothing that we're going to put into the robot that could cause any confusion or break something. So sometimes we'll see beams come in that have a very large metal bracket bolted, like through bolted, some sort of structural bracket through bolted. And that's not something we're ready to tackle yet with the robot. So we have humans taking the really big, weird stuff off before it goes in. And then, yeah, we miss stuff. We're not hitting 100% of these things. We don't have to. Things that we miss, things that we deem not worth it to go after, we just chop those sections out. We just have a cross-cutting system and we just chop those sections out and say, unfortunately, where we are today, we're not ready to efficiently remove that contaminant. Just chop it out.
What has been the biggest challenge from an engineering standpoint?
Yeah, this is a sneaky one. It's been conveyance. This is something that is a perennial challenge at Urban Machine, is moving this material around. When we first started thinking about this problem, we were thinking about residential lumber waste. So think like your 2x4 or 2x6 wall stud, 8 feet long. Okay, that's a little awkward to deal with, but it's not the end of the world. in reality, a lot of this material is coming off of commercial and industrial teardowns. And they have these large timber beams and these structures that can be 40 feet long and 2 feet wide and 10 inches thick. So all of a sudden you have this 500 plus pound beam that's 40 feet long that you have to maneuver around. So we want to try to build a machine to hit as much of this dimensional lumber as possible. So now we have this huge range of material, huge range in dimensions that we have to handle in a single system. The other challenge is that the thing is covered in fasteners and you have no idea where they're going to be. It's like handling a porcupine. It's just spikes everywhere. It's so hard. And it rules out a lot of conventional conveyance techniques, like conveyor belts are going to get punctured, the nails are going to get stuck, like passive roller conveyors, the just nails get jammed everywhere. So we've had to do some pretty nifty, clever things to move this sort of porcupine material through the system. We've taken a couple different swings at it. We're pretty happy where we are right now. We might try to change it again in the future. There's some sort of ideas we have on the roadmap, but it's been sneaky. It's been really sneaky conveyance.
Yeah, I wouldn't have thought that. What can you say what it looks like? What your solution looks like?
Yeah, absolutely. So we file like patents on all the really nifty hardware, but we ended up with sort of this almost like this series of starfish rollers. So it's almost like a rolling bed of nails that can pass the lumber, but the nails can kind of slip through in between. And we spent a lot of time working on the geometry of those starfish so that we can contact and move the wood in a certain way, so that the nails don't get stuck in the starfish a certain way. So it can kind of just trundle along through this thing and be supported, not damage things. And then during removal, we have this pretty nifty high-speed clamping system. So we can kind of like roll the material, clamp it in place briefly while we remove the material, then unclamp and then advance the material again. So we're kind of advancing in these little sort of work chunks through the system.
In high school, I worked for a residential construction company, and I was the low person on the totem pole and was the guy like pulling nails out of lumber. This is a very like kind of sustainability oriented company. So we did a lot of manual salvaging. And I remember how like stuff takes a lot of force to get out sometimes.
It's a huge amount of force. So it can take a few hundred pounds of direct pull force to get a nail out. It is not fun. You'd be surprised the number of folks we speak to that have similar story about like nails are stubborn and they're a pain in the butt. Our removal gantries are burly. We have a 1,000-pound electric linear actuator in there that can move at about 6 inches per second. So we can like a huge like 16 or a 20D nail, even bent over on the other side. Once we get a hold of that thing, it's unbending and it's coming out super quick.
But then, yeah, I guess the clamping is to counteract that force.
The clamping is to counteract that, exactly.
Yeah. But then, oh man, this is bringing back, I'm having like PTSD of like the nail head will break off and then you've got to go figure, then you get the pliers and you try to like still wrench it out. But I guess I'm curious what your manipulator looks like.
Yeah, we call the end effector the big bird because it kind of looks like the beak of like an eagle. It's like sort of this talon sort of beak type shape. It's 4140 hardened steel, kind of comes down to this taper. We can dig under the surface of the wood with it, and it's actuated with this like big pancake pneumatic actuator. So we can pierce down onto the shaft of the nail, onto those beaks with about 700 pounds of force. So we can come in sideways right onto the shaft of the nail to pull it out.
Okay. And you're not depending on the head of the nail to pull it out, then you're just...
No.
Yeah.
Yeah, we just grab and pull.
You got to make sure you don't shear the nail, have so much force that you shear the nail.
We do see that sometimes, especially, we use the same tool to pull staples out. So staples is something that's one of the things we're going through right now is figuring out how do we modulate the force in that thing so that we can pull staples out, but not just snip a leg off of one as it's coming out. So there's more work to do on that end. But yeah, we just bite into the shaft of the nail.
Yeah, I bet that was a fun design process, figuring out what your end effector should look like.
Yeah, it was super fun. We surveyed a lot of these ancient hand tools that people have been using to try to pull out nails for like over a century.
Okay.
So we looked at all these old things and sort of where we landed was sort of a mashup of these different hand tools that, are great principle, but because they're being used by a human, you just can't get as much force as you'd want on them.
What kind of scale do you think Urban Machine could get to eventually? And what does that mean for your hardware and your company even?
Yeah. So, like I mentioned, 37 million tons of this we're generating in the US every year. Think about, we think about 50% or so of that material is actually sellable. Like there's a lot of that just up or it's not the right properties for something that we think we could create a new product out of. So if you do a little bit of math at that and you look at the market price for like random lengths lumber, it ends up being a $16 billion a year opportunity if you fully saturate that 50% of that waste stream. So that's massive. That obviously we get very excited about that. It's going to take several thousand of our machines working across the country to address that. So that's kind of the scale we're thinking is in multiple thousands of machines. It's going to take us a little while to get there. It's a large piece of deployable automation. So we're going to have to take it step by step, really dial in like how do you make one of these large systems? And it's going to be like building a piece of construction equipment. So we're thinking about what does partnerships with other construction equipment or large equipment manufacturers look like in order to get that scale? How do we containerize this thing? How do we make them more shippable? Obviously, reliability is huge for us. So that's a little further down the road for us. It's going to take us, I'm sure, many years to get there. Today, we've only been doing this a little over a year and a half. So we have one deployed system. So we have to get from one to thousands. We got a long way to go. We're building unit 2 in the shop behind me right now.
Yeah, that's a good point. You founded in 2021. That feels to me like really fast progress to have a deployed pilot system at this point and having solved all those problems. Can you say anything about what your kind of R&D process has been like to move at that speed?
Yeah, I think that the mantra I like to use for the team is like, look as quickly as possible. You have to iterate, like especially in the early phases when you're just trying to see if anything works at all. Sometimes the extreme challenge I like to pose in the team is like, some technical challenge will come up and I like to ask, what do we have literally in the shop this afternoon that you could duct tape together and just start to get some intuition on? So we've done the system in the field right now is our third full scale prototype in a year. So we try to keep really tight. And what you can really do that is by focusing on the most important details. Focus on the things that you really don't understand and don't focus on some of the polished things that we don't need for a fully baked product. So you're making sacrifices because of the focus you have on the things you really care about. So we were able to demonstrate really early that we can automate the nail removal process. The cost of that was it looks like hell.
Yeah.
Hiring is a total mess, but that's okay. We don't care about having super polished components at this point. Our first couple systems, a huge amount of that robot was bought off of Amazon.com, which is hilarious for anyone working in automation. Like, you ever touched those components? But the answer is that we can get it in 2 days really cheaply. And when you go to talk to the other automation vendors, they're telling you 6 to 12 months for some components. You just can't afford to wait that long. Yeah, the quality and the reliability is junk, but it allows us to answer those early questions so that we can have that much more information when we go to build the next system.
Yeah, I love that. I'm about ready to move on to the last few questions. Was there anything else you wanted to make sure we hit about your business model or the hardware or anything like that?
Yeah, I think maybe the one thing I'd just like to emphasize is that we have deployed a pilot. Like, it's operating right now. It's sitting up there at the lumberyard. We're processing material. And that is directly because of the amazing team that we have here at Urban Machine, all the folks that work super hard on that and get that out there. I'm really just super proud of them that we got it out there. And yeah.
Yeah, congratulations on that. We were talking about that just before the recording, but it sounds like that's going really well.
Yeah, super exciting, very energizing.
Yeah. What's the next step after that pilot? Do you have other pilots in the pipeline?
Oh yeah. Yeah, we got a full roster. So we're already deep into building the second system. We're hoping that's going to be deployed in the sort of September or October timeframe. And then we'll start building system 3 right after that. So we're just going to keep cranking these out, doing our thing, iterating super quickly. We're hoping that this time next year, we can start to bake in the design a little bit more, call it that polish that you don't have a chance to do in the early phases, and start thinking about so we've really done some rapid, quick, and dirty prototyping to build the first 2 or 3 units. Let's level up and bake in a lot of this design to get to that 10 to 20 units. That'll be the next thing, sort of starting next year, late next year.
Will you still be building in-house at that point, or will you start to bring on manufacturing partner?
Yeah, I think that's probably when we'll start looking at subsystems on the machine. The machine is extremely modular. That was also one of the key development sort of frameworks, is to keep everything super modular. So there's a lot of opportunity to sort of outsource or ship out certain parts of that stack from a manufacturing perspective.
Awesome. Okay, so I have a few last questions that I ask of everybody. How optimistic or pessimistic are you about the future of our planet, and why?
Yeah, I think this one I was thinking a lot about. It kind of depends on the day, honestly.
I understand.
Yeah, I think there's those few opportunities that I think could be really big game changers. And when I see news come out that we're making progress on those, that's when I feel most optimistic. I think that energy abundance is going to be the key to unlocking or solving a lot of these challenges. Just like having free, like close to free, clean energy everywhere. It might be necessary to really earnestly tackle the scale of this problem. So I feel most optimistic when I see news that is pointing in that direction.
Like, what are you thinking? Like fusion?
Yeah, fusion, that's maybe a little far out, but even things like either just solar continuing to get less expensive, or some of these small modular reactors. You see, that's some of the most exciting things that I see, just some of the possibilities there.
I'm really interested in geothermal. One of the early episodes we did was with Quaise Energy. They have a technology for drilling really deep to basically allow you to tap into geothermal anywhere. And that seems really...
I've heard of it. That's super cool. Yeah, that's a huge one, I think, as well. Really untapped area, literally, I guess.
Yeah. Cool. Who is one other person or company doing something to address climate change right now that's inspiring you?
Yeah. So there's another startup in the Bay Area called Gradient. I was found one of my friends, Vince Bermanin, from grad school, and he's been a huge inspiration. This is a personal story. And he's been a huge inspiration to me, just everything he's done with Gradient. He took that thing literally from his PhD research into other lab, did all the early phase R&D, and now they're winning these huge like housing development contracts in New York. He's like really making it happen. He's making it happen in a sector that I don't think a decade ago anyone could have pointed at HVAC as an enormous opportunity in this space, just from a business and from a climate perspective. So he's been a huge inspiration for me.
That's awesome. I'm actually going to record with Vince tomorrow.
Oh, really?
Yeah, just randomly. But I'm really impressed by what I've done. I actually got a chance to see their unit in person and experience installing it. And I think it's really well executed just from a design standpoint.
It's beautiful. Yeah.
Yeah.
They've done an incredible job.
Yeah. Cool. That's a good call out. What advice do you have for someone not working in climate today who wants to do something to help?
Yeah, there's so many opportunities. I think that maybe the two things I would say is go somewhere like Project Drawdown and just start looking through all the different areas for impact, because there's so many of them and not all of them are super obvious. And then see what that tangent possible is for you. Like see how what tickles your interest, what really fires you up in that space, and where do you think you could sort of find that next stepping stone from the skill set you currently have. It's going to take all sorts of skill sets. Obviously, I like engineering. That's so I go try to find stuff that you can build to help this. But there's all sorts of policy, regulatory, marketing, like just a consumer across the whole board. There's so many skill sets that are going to be needed to tackle these problems. So I would say like find the tangent possible from where you are today, and go somewhere like Project Drawdown and see what captures your interest, what you think you could slide into, and then just start looking at projects that are working on that.
Awesome. Yeah, Drawdown's a great resource. Thanks for calling that out. Andrew, that was really fun. Thank you for your time. I appreciate it. And I'm really excited to see where Urban Machine goes from here.
Thanks so much, Dylan.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.